We're going to consider the derivatives of the 6 trig functions, and ideally you would have them all memorized. The first one that you need to know is that the derivative of sine of x is equal to cosine x. Consider why this might be true. If you were to look at, say, the graph of the sine function over one period, so this is from 0 to 2 pi, and we know that the derivative of a function is related to the slopes of the tangent line, so we can see that at this point the tangent line would be horizontal, and that happens to be pi halves. So since the tangent is horizontal, the value of the derivative would be 0. And we can see at this point the same thing would be true. So at 3 pi halves it would also be 0. Notice that the tangent lines start positive and they get to 0. So it starts at some positive value and is decreasing all the way to 0. From this point, the tangent lines have a slope that's negative. So they're just increasing and becoming more and more negative until this point right here, and now they're heading back down to 0. It's flattening out again. When it gets to this point, the tangent lines are 0, and now the slopes of the tangent lines are positive and increasing. Something like that. And if you can recall, that is a cosine graph. So that would be one way to think through why the derivative of sine is cosine. We could also show this to be the case by using the limit definition. Right? If f of x is sine x, then what is the limit as x approaches h of f of x plus h minus f of x divided by h? Right? And we could prove that it must be cosine x using that. Now the second one that is important, and they're all important, is the derivative of cosine x, and that is negative sine x. And I would want you to consider graphically why that must be true. Why do the slopes of the tangents of cosine look like a reflected sine graph? And the third one is the derivative of tangent, and that happens to be secant squared x. And we could prove this a couple different ways, but one way to do this is we know that we want to talk about the derivative of tangent, and we know that tangent is equal to sine x over cosine x. And we can take the derivative of both of those because we know the derivative of sine is cosine and the derivative of cosine x is negative sine x. And since this is a quotient of two functions, we could use the quotient rule here. So the quotient rule is the derivative of the numerator, in this case cosine x, times the denominator, also cosine x, minus the numerator, in this case sine x, times the derivative of the denominator, in this case negative sine x, and all of this is over the denominator squared, so cosine squared x. Now cosine x times cosine x is cosine squared x. Negative sine x times negative sine x is positive sine squared x, and this would be over cosine squared x. And cosine squared x plus sine squared x is equal to 1. And 1 over cosine squared x equals secant squared x. So we've just shown algebraically, using two derivative facts, what the derivative of tangent must be. So we don't actually even have to have that one memorized as long as we can derive it, although it's useful to have it memorized. I'm going to tell you that the derivative, oops, that's way too big. Sorry, let's erase that. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is equal to secant x times tangent x, and the derivative of cosecant x is equal to negative cosecant x cotangent x. Now I would encourage you to derive all three of these using sine and cosine and the quotient rules. At a minimum, make sure you have all 6 memorized. Now, you may be wondering, all right, well, how could this work if I had a problem? Well, an example might be something like y equals x squared sine x. This is the product of x squared and sine x, which means to find the derivative of y, I would need to use the product rule. The derivative of the first function, 2x, times the second function, plus the first function, x squared, times the derivative of the second function, in this case, cosine x. That's our derivative.